So you have officially finished Calc 1, half of Calc 1, sorry. I was going to say Calc 1. So half of that. So now the rest of the time we are going to do the second half. We should finish in good time. But this, we're going to take what we did and kind of turn it all around. So it does get like confusing at times, but you just got to keep remembering what you know and reminding yourself what you know, so you should be good. But this, and remember when before we got to derivatives, we had to do all the limit business. Okay, it's not going to take us quite that time to get through to the meat of this. I am. But it does take us a minute to get to the meat. So just be
Like how, like one, is that
like
like
one semester.
Oh, okay, so is that like, the AB, like that, like Calc 1, Calc 2?
Well, BC is Calc 1 and Calc 2. We don't ever get to Calc 2. We have done half of Calc 1.
Okay.
Were you all here when, did Sophie and Charlotte, no, they came in my other class and they were already doing this part. And I was like, wow, you're really fast. And she was like, yeah, remember we got to be done in the semester. I was like, yeah, that's right, I forgot. Okay, so suppose from 7 a.m. to 9 a.m. of a road trip, you travel with the cruise control set to exactly 75 miles per hour for 2 hours. How far would you have traveled during this 2-hour time slot? How much? 150, because you take your rate times your time to get your total distance, okay? Now, that's theoretic, no breaks, nothing, which is highly unlikely, but that's what we're going to talk about. Okay, so if we have a graph modeling, here's 75 miles per hour, there's your velocity, here's 75 miles per hour, here's the time frame. I just did a little stop, so I didn't have to put them all in. How would that look, total distance? What is your function? If it's 75 miles per hour the entire time, what does it look like? A straight line. What kind of a straight line?
Horizontal.
Horizontal, good job. So from 7 to 9, we have a straight line, and then we have this, okay? Total distance, if you look, this is, I don't need those. Okay, so I got 75 right here and 75 right here. So you have a total. So if you look here, area of the rectangle is the same as distance, and let's be clear, total distance traveled. Okay? And we'll revisit this a lot because it's like, wait, geometrically it's a rectangle, but it's not, we're going to, transfer pretty much everything to rectangles. Okay. All right, so let's look at a velocity. This is more probably appropriate velocity where you start with no velocity. You ease up, you say, okay, I'm going to drive this way, and then I'm going to slow down. Okay, it's probably not perfect parabolic, but probably closer than, 75 miles an hour because we can't really start there. Okay, so same 2 hours. Let's talk about 7 to 9 area right here. Okay, how would we figure out total distance in this area? Any suggestions about what we could do? Define that area because we're looking for area / total distance because we just said that's the same thing. Remember, anyway? Any suggestions about how we find the area of that? You're not thinking, or you're not responding, or what could we do?
I mean, you could take it all the way up to where it's like, it's like you can split it into a rectangle,
Okay.
and then whatever's up there.
So even if you do a rectangle right here, you have a little overboard, right? This is
I'm saying like draw horizontal line.
A horizontal line where
At
it would
the,
make
at
it.
the
Okay,
highest point,
let her talk.
at the highest point that you can without. So that you have like a.
So that would be there.
No.
Come on up.
Like.
Okay, 7 and 9. Like, this is the last line that doesn't include the curve, so then like you can easily
Do that.
get this one, and then I don't know what you're gonna do. The rest of it.
Okay.
Figure that out.
So you got 1, 2 times, what is that? Okay,
Like 6-ish.
so 6, this is 75.
Oh, well, like 6 little marks.
Okay,
That's what I was going.
all right. So we could find the area of these easy enough. What would we do with this extra?
You would get an area of a second, when we did the circle. Remember when we
Say a sector?
Yeah. You did
Okay.
a center, right?
It's not a circle though.
I know, but I was.
Okay, could we just estimate and just guess?
In a triangle?
Yeah. Or could we just, okay, so we're gonna have to estimate the pieces, and honestly, here's how we're gonna start it. It's gonna be, and that's why I was thinking about that in case you wondered where was I going with that. It's gonna be in terms of maybe a rectangle that looks like this. Okay, where this is a overestimate, right? So we could do that, and knowing we got 2 pieces that are a little bit more. Okay, we could go a rectangle underneath and do this one and this one, and then we're under it, right? We're under the actual. Okay, calculus honestly is going to tell us exactly what that area is. Okay, so that's kind of where we're going. Okay, but for starting here, we are going to find areas of rectangles and add them up. Okay, and yes, we'll have to have either underestimates or an over. It won't be exact. Okay. And we can talk about how we would get it to be more exact. I think that's on the next page. Okay, so let's look at the parabola v of t equals t squared. Okay, I'm only looking at half of it because t starts at 0, because there's no such thing as negative time. All right, so that's why we're only looking at half of a parabola here. This is the parabola t squared. Okay, now take a look at the first 2. I separated into rectangles. And how wide are these rectangles? I'm going from, as you can see, 0 to 5. There are 1, 2, 3, 4, 5. So there are 5, oopsie, rectangles, right? How big are they? They're 1 wide, yes. Same thing here. The change in x, this is the change in x, 1, 2, 3, 4, 5. We take 5 and divide it by 5, we still have 1. Okay, this is an overestimate because I got this that I'm counting that's really not. And remember, just to be clear, we are talking about the area under the curve. Okay? So between the x-axis right now, we'll change that up a little bit. This is a underestimate, right? Because we haven't counted this, we haven't counted this, we haven't counted this, et cetera, et cetera. Okay? Now, let's look down here and say, oh wait, let's go to 10. N means how many rectangles I've got. Okay, what do you notice first about when n equals 10 about the area that we're looking for? Are we closer or further away from it? We're closer because we made our rectangles smaller. In this case, what is our change in x, which is each little piece of this? What's that? A half, that's right. Okay, same thing here. This is an overestimate because we got all this that we counted that really isn't under the curve. This is an underestimate because we got this that we didn't count. All right. Now I went to 50 little rectangles, and we're getting closer, aren't we? This is way closer to the actual area under the curve. Okay? You see where this is all going? You see a limit in your future? Because if we just kind of say, all right, I'm going to 50, then I'm going to 100. I mean, think about those little spaces in there, those little black spaces. If the more you squeeze in there, the less that space is. So that's where we're going with the limit. Don't worry, we're not going to, as n approaching infinity, that's what we're going to do. But don't worry, we won't have to do limits. It's just the whole idea of it. Okay? But that's the idea, is that way we get to as many as we can squeeze in there, there would be no space. And there isn't. This change in x would be, how do we get that change in x? Sydney said it's 1 over 25. Where do we get it? We take the space. And so that's 5 minus 0. And we divided by how many we did, which is 50. So it's not,
Oh, 1. I'm
yeah,
sorry.
1, 10. Okay. Okay. So you have, and let's think about how we would find this. This would be very tedious, but let's think about how we would find the area of all these little rectangles. We'd take 1/10 times, actually, let's not start with this one. Let's do this one, because it would be a lot easier to just represent. All right, so our change in x, or our width of our rectangle, is 1, right? Length times width is the area of a rectangle, right? Okay. Our width is 1 every time. What's our length? Where would we get that? Like this right here would be your length. From there, from here to here is another length. Here to here is another length. Here to here. Here to here. Where are those coming from? It has everything to do with this curve here. This number is 1. What's this number right there on that curve?
Is it x squared?
Yes. So this is the f of 1, or 1 squared, or 1. What's this number? The f of 2, or 2 squared, or 4. Okay? F of 3, 3 squared, 9, f of 4, etc. 4 squared. Now we don't ever use the f of 5 because we didn't do that. Over here, what was the f of this? F of 0, 0. Okay, over here, when we did it from the other direction, the height would be here, then here, then here, then here, then here. And we don't use that one, right? We're doing. Okay. So we used the f of, what's the height of this? Oops, it's up here, right? The f of 5? What's the f here? 4. And, okay. And, oops, I missed one. F of 1, right? Okay. You still have 1, 2, 3, 4, 5. You had 1, 2, 3, 4, 5 here. It's just a different one. This would be way more than this because we started at 5. Here we didn't do 5. Okay, so let's get to what we're talking about here. This is called the rectangular approximation method. Okay, the RAM. All right, we have 3 different RAMs. And remember, this is the method of dividing into rectangles, finding all the area of rectangles, and that's your approximate. Please know that it's an approximate. We'll be able to do the exact in a little bit, not today. But this is approximation method for the area under the curve or total distance, which, remember, they're one and the same. Okay, the R, the L, and the M, what do you think the R stands for here? We haven't really talked about that. Let's look at the figure. The difference between this one and this one is the R and the L. No. The RAM is the rectangular approximation method. No. Right and left. That's what we're doing. From the right rectangular approximation method, and left, from the left. Okay. And what do you think M stands for? Any idea? Middle, midpoint. Very good. Okay. And we're going to do these here in a minute, but let's figure out. It's midpoint. Same idea. Same idea. Technically, midpoint. Okay. So, no matter which rectangular approximation method we use, we are adding products of, remember, this is length times width. Okay? Product is L times W, which is really F of the particular X, and the change in X. Okay. So we got 2 here. I just reran the ones from this previous page. One of them's up left, RAM, and one of them's are right. Okay. How do we know the difference? Well, we start from the right to find our height, or we start from the left to find our height. So which one's this? Yes. Because we started with this. There's a left, 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 left. My left hand, my left. There's 5. 1, 2, 3, 4, 5. Okay, over here we started from the right and found height. Right, 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 right. The height of this, here's my change in X, which is 1. Okay, this is 1 times, what's my height here of this? We're up here. What is this right here? F of 5. This is length times F of 4. This is 1 times F of, that's 3. 1 times F of 2. And 0 times, no. I missed. Oh, okay, sorry. 1 times F of 1. Okay. Over here, we have to right F of 0 times 1. This is 1. So this rectangle has 1 times F of 1. 1 times F of, it's right here. This is the height. 2. Here's the 2. 1, 2, 3, 4, 5. F of 2, what's the height of this, where we are? What's this? There's 3. And that's a big mess, but 1 times F of 4. Okay? And in this case, the F is the X squared, but we don't need to go there yet. So that's just how you do it. Are you ready to try one?
Is coming from the right always the first maybe coming from the left?
No, that's a good question, though. It depends on the function. Like if you had, does everybody understand the question? That's an excellent question. If you have a function that's going like this, then it's going to be, it just depends on the increasing, decreasing of the function, honestly, if it's an over and under. It doesn't really have anything to do with the right or left. I didn't show you a midpoint, but we'll do one here. All right, so I need you eventually get your calculator. No matter which brand we use for adding product, where I said that, okay? The area of the region S that lies under the graph, okay, of the continuous function is the limit of the sum of the areas. Now, we aren't going to get into the limit yet. We're just going to do an approximation. So we'll revisit this, and then we can also look at that sigma notation. Did we do some sigma notation last year in pre-calc? Did we? Okay. Okay, we may have. All right, but anyway, we'll revisit that. So get your calculator out and put in x squared sine of x. Make sure you're in radians. You shouldn't have moved out of radians, but this is going to be ugly. Yeah, in here, x squared sine of x. Make sure we're in radians. It shouldn't. All right. Okay, so the first thing you would do is graph. So that's already done. And then the next thing we're going to say, all right, graph, we are dividing to 3s. Okay, we're dividing by 3. Here's 4, so 3 must be right here. So that's your end. Your 0 is the beginning. So we are dividing up this area under the curve. Okay, you can hardly see this, and we want to estimate the area under the curve from 0 to 3 using 6 partitions. Okay, we haven't formally discussed how to do this, but this is how you find the change in x. This is your A and your B, like it always is. So in this case, 3 minus 0. And the n is the number of partitions that you want, which is 6. So this is how big our partitions will be, and that will be 1/2, right? So I'm going to divide into 1/2, 1, 1.5, 2, 2.5, 3. Okay? This would not be one we'd ever attempt without a calculator, just because there's way too much involved here. All right. Now you're going to start with drawing your vertical lines at all those intervals. Okay. Now we're not going to. So basically, we are going to talk about as close as we can do this. I don't know what's happening, but we're going to talk about that area in terms of rectangles. All right. Okay. It says to use right endpoints. All right. So we're going to do the right. Help your brain out. Start on the right. Don't start on the left, because that's like crazy to your brain. Okay. So the right endpoint on the curve itself goes straight over. Yes, we're going to miss all this, but that's okay. It's all going to come out in the wash. All right, here's from the next right, goes straight over. The next right, I'm on the curve when I make that. See, we just made up for that. We just didn't miss. We missed here. We made up for some of it there. Some more of it here. Some more of it here. And I'm not sure what that is, but it's probably nothing would be my guess. But it's very small anyway. Okay, so now you are comparing this. Get my yellow out again. Get kind of messy. We're comparing this curve. And we're saying really, oops, that was really cool. Let's do orange. Okay, that color, we're going to compare this area. This is the actual area. And you are going, the best you can do right now is whoops. I didn't mean to do all that. Okay. You're comparing it. Oh, wow. Did I? Yeah. Okay. Let me try that again. All right. Let's try it. No picking up.
You got 30%.
I didn't pick it up. I just paused. There we go. Okay. So we're going to actually find the area of that green But it's gonna be close, and we can only be as close as we want, you know, as you can be, depending on, they're gonna tell you all this information. You don't have to make any decision about, should I do right, should I do left? They're gonna tell you that. They're gonna tell you how they want it divided, how many partitions they want it. So all those decisions are already going to be made. Okay, so now we just have to do the math. Okay, I'm gonna spread it out. And then while I'm doing this, I'm gonna do an area, I'm gonna do a right ram. Okay, and you'll also see this as R6. Why 6? 6 partitions. Why R? From the right. So that's kind of how you keep it in your head, but we've already divided it, so we should be good. Okay, so I should have 6 rectangles when I'm done. So length times width 6 different times. Okay, so here we go. My width of all of them is going to be 1. So length, I'm going to do width times, right. Sorry, what did I say? Oh, sorry. Okay. So I'm going to do width times L because I know the 1/2. All right. So here's my first rectangle. Over here, all the way to the right, what's the height of that one all the way to the right? It's f of what? Okay, we're going to do this first. Then 1/2 times f of, what's the next? What's this height? Yes. No, I mean, if you can keep it straight, it's up to you. F of, what's the next height? 2. See where you are, 2. Okay. F of 1/2. 1/2, I'm at 1, 2, 3, 4. I got 2 more. F of, I'm right here, 1. And half of f of 1/2. That's at my 6. 1, 2, 3, 4, 5, 6. So it's easy to keep track of. You got 6, you're done. Okay. Now this is when you're going to look them up in the calculator. I've already done this just so I would have them. Now, is there a shorter way that I could write all this mess? What can I do?
1 times f of 3
Okay.
plus f of 2.
Good.
Keep going to that.
Okay. If I'd started there, you'd be like, wait, why are you doing that? So now you can start there if you think of it. But it's just 1/2 factored out, basically. Okay, so now I got to grab my numbers. Now, when you put this in the calculator, and you probably are going to do value, unless you're going to, oh, wow. That's not a good window, but, oh, gosh. Yes, you can set the table like I did. You all know how to set the table? No? Okay, you go second window, says table set right above that in blue. And we want halves. It doesn't matter where you start, but I'm going to make my change in table, that little delta table, to be 0.5. And then when I go over to my table, it's set up what I want it to be set up as. Okay? And that's where I got this. All right? Now, if you look at this, if you highlight, you can get more digits down at the bottom. I would not go less than 5. Okay, I know that's very tedious when you're getting all these, but don't go less than 5, otherwise you're going to end up being a little off. Okay? So I'll start putting these in here and you can do the same. And I lied, I said I was going to 5, but I'm just going to 4 just because. You go to 5 and see if there's any difference. Sometimes there will.
5 does.
Yeah. 5 is just, if you're rounding immediately, 5 is usually pretty safe.
Can we chop it off at 5? Or
Yes, you can just chop it. Yep.
I round it.
Or you can round, it won't matter, because when you round to 3, then you'll have taken care of that. But 5.5 is my last one, right? do the math.
Oh, wow.
I'm trying to get it out of the way and you're just enlarging on me.
But we rounded 3 in the last
Yes. And then we should all be the same, just like, unless you put that in your own way. Okay,
one. You want us to say,
yes.
probably 927.
Wait, did you take it times half?
I got 5.892.
Okay, I have the answer right
You're
here.
at 927.
Oh, gosh.
Your legs are all the way down.
I know.
Your razors are all the way down.
Okay, thanks. All right, there's your right RAM, 5.927 should be the final answer after the half's already done. I did 5 digits there, but, okay. 1/2 of whatever
Did you say unit
equals,
squared?
yes, 927-ish, okay? What was this number before you did the half? Anybody do it?
11. It was, no, I didn't.
11.8534.
Thank you. Okay.
Well,
All right, so that's how the RAM thing works. Sometimes I've seen these on the non-calculator piece, but certainly not one this complex. The function is, and sometimes I'll show you in a minute too how we can do it without the actual graph. The graph to me is important, and so then when we're doing graphs on the homework, that's why you have so many of them, because when you're going to do right, when you're going to do left, when you're going to do n equals 5, when you're going to do n equals 10, but that's why you have so many. And when she snipped that to you, she only gave you one. So you can use those or you can just rerun that. Okay, so we're going to do the same thing, except now this time we're going to use left endpoints. Okay, so we're still going from 0 to 3, there's 3, okay? We're still doing 6, so that's still half 4, the change in x. So we're going to do 1/2, 1, 1.5, 2, 2.5 to 3 again, okay? But this time we're doing left. So we're going to start with our vertical lines, okay? And we're going to start with the left, okay? So here's my left, 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 left. Okay. So I got 1 here, 1 here, I got 2 here, I got 3, I got 4, I got 5, and I got 6. Okay. 1, 2, 3, 4, 5, 6. All right. It should be very close. I don't know if you saw the numbers, but it's basically the same. It's going to be close, but it'll be slightly different if you use the point. Okay, let's get that going here. And this time we're doing L6. So we're going to pull out the half from the beginning. Okay, we're going to do the F's. Just to be clear, we're starting from the left. What's the first one on the left? 0. And then half. And then 1. And then 1.5. I'm at 1, 2, 3, 4. Then 2. And finally at 2.5 we stop. Okay? All right. So that's how it works. You find your numbers. And we could estimate it, but that would be a major estimate here. All right, we got numbers over here. Let me just grab those again. There we go. Go ahead. Where'd my numbers go? Yeah, we're taking off this one and grabbing this one, so it'll be slightly different. But not hugely different. One, two, three, four, 5, 0, and 0. I know you don't have to put the 0, just helps you to kind of remember that we had 6 and we should have 6.
So
At
when
7, you have to make.
you're coming from the left, I guess, you always put 0.
Yeah, but you're not always gonna have 0. You could start from 2 to 5.
I meant like after 0.
Yes, yes. But you're always gonna start from the left. That's the left, that's the right. So, again, you're just helping your brain by starting from the left or starting from the right, depending on what you want to do, okay? And you should have gotten what? What did we get? 5.297?
I know wait, no. I got 5.2. I got 5.2.
Okay. Where are we? All right, well, let's add them up.
Did you round it, you see?
No, I did on the calculator, so I have a program that I'll give you eventually, but
You like the whole always say if it's, like on the left.
they will tell you whether you want it to be on the left or to the right. You never have to make that decision. And, we gotta do a midpoint one, so you know what that means, okay? Because we haven't really talked about that. But yeah, they'll tell you everything you need to know. They'll tell you the function, they'll tell you left, right, midpoint, they'll tell you the interval, because otherwise you're all, okay.
Is the next page the same?
Yes, but we are going to do, do you want to just find a new equation? Let's do.
Yeah.
And we're going to do midpoints. Midpoints. Not mid-end points. That doesn't make sense. Okay, let's talk. I meant to change out, and I guess I didn't get it done. Okay, let's find that equation here.
You maybe the next page.
No, I think I just grabbed the one. So let's do 7. Let's see what this looks like. I think this is all right. Let's do y equals 7x minus x squared. That's my function. I'm going to set up a standard window and see what I got to adjust to it.
Isn't that bad?
Okay, so let's talk about I'm going to change the parameters, so don't do anything yet. Let's go from -1 to
I feel like that's
8.
good, like,
Okay, and that's 10, 9. Let's do 9 partitions. Okay, I'm doing midpoint, right?
Wait, so is our interval -1 to 9?
Yes. Okay, so we're gonna do 7x minus x squared. Get my interval -1 to 8 using 9 partitions for midpoints. Okay. So the first thing you're gonna do is wanna graph it. So it looks like, oops, and this is, your zeros are 0 and 7, right?
So why would you 9?
You'll see here in a minute. Okay, -1 is right here. So we have some underneath, which I wanted to show you. And then we also have some underneath over here, because this is 7 to 8, right? Okay, so we're doing this whole, this is my area. Okay, what we're really talking about. Finding the area of, okay. Now, we're gonna do midpoints. Okay, they're gonna be ugly because they're gonna be halves. Midpoints are, how about, no, we can't. Never mind. I was gonna say, sometimes you get a midpoint, which is a whole number, which is nice. But, because like if we did 8 and we divided it into 2s, it wouldn't be a midpoint. I didn't plan that very carefully. Okay. So let's see, our midpoints are, we go from -1 to 0 to 1, 2, 3, 4, 5, 6, 7. Dang it. This is not, I'm going to start over and do a real graph. You all, are you ready to go?
Yeah.
What'd you use for your top x? I'm going to do -2. I just want to be on the other side to 10 percent off, doesn't it?
Just do 15.
Okay. So -1 to 9 is, if it's -1 to 8, I would put in my window -2 to 9. That way you got a little bit of room on both sides. And then we don't need -10 because it doesn't go that. Okay, and you went to 15 and that covered it?
Yeah.
Awesome. Thank you. Okay. All right. Okay. Actually, I had a way it worked. Okay. So I'm drawing my vertical lines here. No. Well,
Doesn't it have to go by 9?
no, we don't draw them in the middle. Because that's how we divided them up. Do what? We got 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 7 in here and 2 on the ends. Okay. Now the height is determined by the midpoint, but the rectangle still starts and ends there. Shadow is making me crazy. Okay. All right. Now here's the height. We have. I'm not gonna put my numbers in yet. All I'm worried about now is that I have from -1 to 8. Okay. So what's the middle of -1 to 0? -1/2. So at -1/2, this is the height of the rectangle. And then we go over. See, we're still using that same vertical. Okay. And then next one is +1/2, right? The midpoint of 0 and 1. Okay. Middle goes like this. All right. What's the next half? 1.5. So go ahead and have 2.5. 3.5, I need to find tip 10 here. 4.5. Make sure you're using the curve for your heights, because that's where we're going to get those values. We're getting from the F of the curve. 6.5. A little overage there. And 7.5 right there. Okay, that one was a little weird, but I didn't make my rectangle all the way down. What happened there? Okay. It's important for you to get the visual of that, and now it's also important for you to grab the right numbers. Okay. Remember changing X, we already kind of did that, was 8 minus a negative 1 over 9. Now you know why I use 9. That cannot be that has to be a whole number because that's the number. Well, that doesn't have to be a whole number, I guess. It would be awkward to not be a whole number. Okay, so what's my change in X is 1 every time. So I'm going to do M, midpoint 6 for the RAM. I'm going to do 1 times. Okay. The F of the middle, you can start with either end. Remember, we need not 6 of them, but 9 of them. We corrected that. Wow, that's a first. Okay. F of negative 1/2. F of 1/2. These are all 1 apart. That's what this is. They're 1 apart. F of 1.5. F of 2. F of 2.5. F of 3. F of 3.5.
Wait, why are we just doing half?
I
thought we were doing by 1.
They're by 1.
No, they're not, because you did.
Oh, duh.
1/2 to 2.
Silly me. Two and a half. I was like, wow. Okay, thank you. 5.5. We got to go to 7.5. That's the last one, right? I should have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Why I counted because I can't. All right, go to it. The answer here from the calculator, it should be close. You don't really, because it's just whatever it is.
It's just
Yeah. Did y'all get this?
Yeah.
Okay. And you did notice that you had a negative 1 on the end and a negative 1 on the other end, right? The negative number. Yes. This was negative. This was negative. You have to include that as is. It takes care of itself. That's a distance. And so these really are, eventually we'll talk about where really we're talking about total distance. We really need to, this is like going left, and you really need to include that differently and that differently, but, okay? Anybody not get 50.25? We need to work the numbers here. All right, okay. So that's midpoint. It's a little tedious. Okay, you all had a table on your last test. You remember?
Yeah.
I didn't see very many people drawing it. Okay, I saw Emma drawing it. That was like the star of the test. Do you all remember making a sketch of it? Yes, you did. Okay, and here's the problem. You were looking for. It was like. You're looking for what, I was giving you F prime, which I'm doing it again with velocity, that's your F prime. And you were trying to figure out what part was negative And there was a 0, remember, there was a 0 at -2 and 2, and then in between they're all negatives, right? And a lot of you chose the next one to be where we're negative. But remember, if you had drawn that, your -2 would have been here, and then everything's underneath, your 2 would have been here, all that. You wouldn't skip this piece. So the graph, the visual, real quick sketch might have helped you. It also might help you here, okay? But let's just talk about what they're giving you here. Okay, so the AP people that write the tests are really big on tables because it's conceptual. It doesn't take a lot of computation, and that's what they're after. Okay, so I'm giving the velocity just like these are all the velocities, from the very beginning. I called that the velocity over here. What is the velocity? V of t. Okay, so all along, that's what I've been giving you. Now I'm just going to give it to you in a table form. Okay, so velocity, inches per second, and time in seconds. All right, it's from 0 to 10 seconds. All right, and this one particular is using 1, 2, 3. It's using a consistent interval. It doesn't always, so you got to be careful about that. All right, so we are using 10 subintervals of length 1. Okay, we're going to do, again, let's do a visual real quick. 0, 0, 112, 222, 310, 4, 5. It doesn't take that long. 5, 13. Okay, etc., etc., etc. I'm not going to do it, just so you get the idea. So you have that, then you're going to do this, etc., etc. Okay, so they are giving you the velocity, they are giving you this value right here. It doesn't say right or left. It doesn't. Usually it does, but we got 10 intervals. So let's say we want to do left. Okay? All right, so this first rectangle, what is its height from the left? And draw it in there, right? It's 0, right? That's, okay, so we know length times width. The width is going to be 1 for the whole problem, correct? Now be careful, it is not always. I already said that, but it is worth repeating. Okay, what's my first height is, my first length is 0. What's my second length?
You mean height, right?
Well, this is my width, this is my length, it's also my height, yes. The second one is 12, it should be right over here. Okay? And what's my third one? That should be right here. Okay? That's 22 high. Okay? And my fourth one is, my fifth one is, my sixth one, my seventh, my eighth, my ninth, and my 10th. And that's why they didn't tell us if they wanted right or left, because they're both zeros on the end, so it wouldn't have mattered what we did. So, but this is an actual AP problem, so. And that's why I made sure we're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we either start at the left, start at the right. If they don't tell you, it's not going to matter. But usually they tell you because it's not usually 0. But this was just a visual to get us going. You don't have to do that unless you need to. So what is that number? 1 times, anybody add them up yet? 88 sounds good, actually. So that's 88, and it did tell us it was inches per second. So when we take inches per second times inches times seconds, what do we get? No, just inches. Okay, and again, you're thinking of area. We are looking for distance. Remember, the number is one and the same, but the unit would definitely be inches, not It's just squared because we're doing distance instead of the whole rate times time thing. Does that one make sense?
Yeah.
Okay. That's basically, we're good.
Yeah.
These are your graphs.
I think you gave us 2 pages of,
I gave you
you gave us like 92 on.
Yeah. I didn't know, I know there's way more than you need. I just kind of doubled. Here's 3 here. And then one year it's like, wait, you didn't give us enough. So then I added some more. So you should have plenty. There's 6. If you, and you got them on your snipped things too. So anyway, this was back in the paper days. I didn't want them to have to draw. You're all